Okay, we're going to walk through an example of double time. And for double time, we're going to use our continuous growth formula. So we need to find our value of A and our value of R in part A in order to set up an equation. And then once we set up the equation in part B, we're going to use the equation to find the population size of the bacteria after 2 hours. So it says a research student is working with a culture bacteria and it doubles every 15 minutes. So in the initial population was 2. So we know what our value of A is. A is 2 because that's our initial value. So all we have to do now is find our value of R. Now we're going to use the information that's given to us in the problem to plug in for T and Y so I can solve for R. The information that's given to us that we can use for that is when T is 15 minutes, Y, which is our bacteria, it doubled. So that would be 4. Because it starts at 2 and in 15 minutes it doubles. So that would be 4. But here's the tricky part. It says T represents hours. So I want to make sure that I don't use minutes. I want to change 15 minutes to hours. And in hours, 15 minutes would be 0.25 hours. It's a quarter of an hour. So that means I have the 0.254. This is what I plug in. This is what I get out. So I'm going to use that information to plug in to solve for R. So I'm going to plug in 4 for Y. And I'm going to plug in 0.25 for T. So I'm going to divide both sides by 2. So I get 2 is equal to e to the 0.25 r. Now this is an exponential equation. So what we're trying to solve for is in the exponent. So I need to take the log of both sides, or the other way I could do it is just put it in log form, and that way I can solve for r. So if I put this in log form, this is base e, so I'm going to use natural log. So I have natural log of 2 is equal to 0.25r. That's my exponent. And then to solve for r, I'm just going to divide both sides by 0.25. So I have the natural log of 2, and I'm going to divide by 0.25, and that's going to give me my value of r. Now, when I put this in my calculator, I want to keep all of my digits to maintain accuracy. So when I take the natural log of 2 and I divide by 0.25, my decimal values, if I write them all down, is 2.772588722. So my equation is going to be y equals my initial value, which was 2, e to the power of my value of r, which is 2.772588722, and then t. Now, that is my equation for part A. Now, for part B, I'm going to use that equation to find the population size after 2 hours. Since I set up T to be hours, I can just plug 2 right into my value of T. So I have Y is equal to 2e to the 2.772588722 times 2. I'm going to use the E button on my calculator, my exponential function, which is above my natural log. So let's see, I'm going to hit second and my natural log button, and then I'm going to put in my 2.77 number, keeping all the digits, and then multiply by 2, making sure that that's all in the exponent. So when I take e to the power of 2.77, that whole long digit, or that whole long decimal, and then I multiply that by 2, that gives me 255.999. Then I take that and I have to multiply it by 2, and I'm going to get 511.9999 bacteria. And it says round to the nearest whole number, so my final answer is going to be 512 bacteria.